Here's the mean value theorem. It says if f is continuous on the closed interval from a to b and differentiable on the open interval from a to b, then there exists a number c in the open interval from a to b such that f prime of c is equal to f of b minus f of a over b minus a. Now, if you know that we know what f prime of c is. F prime of c is the derivative of the function evaluated at c, which is also the slope of the tangent line at c. And then on the right side, that should look familiar to you as well. If you notice that this is the slope of the secant line joining the points a, f of a, and b, f of b. So right here we have this slope of secant line joining the points a, f of a, and b, f of b. What the mean value theorem tells us that if, again, we have some conditions. If f is continuous, that's the first condition, on a closed interval, that's the first condition, and the second condition is f has to be differentiable on the open interval from a to b, then the conclusion is that there is such a c that gives us the slope of the tangent line at c equal to the slope of the secant line joining the 2 points that are involved. So let's take a look and see what this is actually saying. To the right, I have a graph. It's not the best looking graph, but I drew the graph of a function. We'll call that function f. Notice that I put 2 points on the graph. I put the point a, f of a, and then I put the point over here, b, f of b, and I drew a line through these 2 points. Since the function is continuous and the function is differentiable on the open interval from a to b, then the mean value theorem applies. So there has to be a c in here somewhere where the slope of this secant line that I've drawn is equivalent to the slope of the tangent line at that value c. The secant line to that point, and I know I've written that as a big point, that will be the c. As you can see, these 2 lines are parallel, which of course means that their slopes are the same. So we found a value c that is guaranteed by the mean value theorem for this particular example.